Video is to allow you to correct your homework 6.2.7. And the problems, of course, are 6.134 through 6.139. So the first question, 6.134, says one way of thinking about solving equations is to work to get the variable terms on one side of the equation and the constants on the other. So again, that's one of our goals with solving equations. Get the variable terms on one side, get the number terms or constant terms on the other. And so they ask you to consider the equation 71 equals 9x minus 37. So mathematically, as a first step, you could subtract 71 from both sides, or you could divide both sides by 9, which means every term would have to be divided by 9, or you could add 37 to both sides. So what they want to know is, does one of those steps get all the variable terms on one side of the equation and the constants on the other? And of course, the answer is yes. Adding the 37 to both sides would mean that you have a number term by itself on the left side and the variable term 9x by itself on the right side. So yes, of these three processes, all of which are mathematically correct, the one that's the most efficient, or probably the easiest way to solve it, would be to add 37 to both sides of the equation. Then they have you solving it. And again, make sure you show your steps. So make sure you've written down the original equation. Then, as we talked about, you're going to add 37 to both sides. When you do that, this zeroes out. So 71 plus 37 is 108. Equal sign comes down. 9x comes down. And this term has been zeroed out. Now we have 108 equals 9x. So we have the number term on one side, the variable term on the other, but we want to find out the value of 1x, not the value of 9x. So we're going to divide both sides by 9. 108 divided by 9 gives you 12, and 9x divided by 9 gives you x. Again, it's creating a giant 1, so 1x or x. And that would be showing your steps. It did not say you had to show your check, so you do not have to. However, if you did, there's certainly nothing wrong with that. It's good practice. For 6.135, they want you to solve for x, and they encourage you in this case that you may want to simply use mental math. All right, so x minus 2/3 equals 1/3. Mathematically, the way that we'd solve that would be to add 2/3 to both sides. When we do that, we get x by itself on this side, which is our goal, and the number term by itself on the other side. And so that it ends up being x equal to 1. And again, the mental math would be the 1/3 plus 2/3 equals 1. It also should hopefully make sense that 1 minus 2/3 does equal 1/3. And it didn't say we had to check, so we don't. Same concept here. You're continuing to solve. So 4x equals 6. You would divide by 4. Again, that's because we don't want the value of 4x. We want the value of x. So this creates a giant 1. So we get 1x or x equals 1 1/2, 1 5/10, or if you went with 1 1/2 as a mixed number, that'd be fine too. Again, in all these cases, it did not say you had to check. For this one, you would subtract 4 6/10 from both sides. And again, you get this zeroing out, so x equals, and that's 8 36/100. This one especially, you really want to kind of think about mental math, because what number divided by 7 is going to equal 3 7s? Well, especially the way that they wrote that, you can see that, you can think of x divided by 7 as a fraction. So 3 7s would equal 3 7s, so x must equal 3. Now, again, there is ways to also solve that mathematically with showing steps, but in this case, they encouraged you to use mental math if it was helpful. 6.136, due to differences in gravity, a 100-pound person on Earth would weigh 38 pounds on Mars and 17 pounds on the moon. So what would a 150-pound person on Earth weigh on Mars? And then they want you to explain it. So what I would probably do is set that up as a proportion. So I would say a 100-pound person on Earth would weigh 38 pounds on Mars. So that creates the ratio on the left. And then I want to know, or they want us to figure out, how much a 150-pound person on Earth would weigh on Mars. So how much they weigh on Earth needs to go across from how much they weigh on Earth. So that's why I've aligned it this way. And how much they weigh on Mars is my unknown. Now you might say, well, we haven't done anything with the idea of how much they weigh on the moon. Well, that doesn't fall into this question. So yes, we're not addressing that yet. But once we're set up with our proportion here, we can do our cross products, which again, remember, means to multiply diagonally the two that you know, 38 times 150, and then divide by the third value. Right. So when you do that, you end up getting 57 pounds. Then it says, how much would a 50-pound person on Earth weigh on the moon? So now we are going to address what they weigh on the moon. So I'll make that a different color here. And that is, again, a 100-pound person on Earth would weigh 17 pounds on the moon. So that's our starting ratio. 100-pound person on Earth would weigh 17 pounds on the moon. We want to know what a 50-pound person on Earth would weigh on the moon. So again, what they weigh on Earth would go across from what they weigh on Earth. These two need to be aligned. And how much they weigh on the moon is our unknown. So again, cross products, multiply diagonally across the two that you know, and then divide by the third value, which gives you 8.5 or 8 5/10 pounds. Again, you are allowed a calculator for these. For an additional challenge, and this is part of our homework, if an astronaut on the moon weighed about 34 pounds, what would they weigh on Mars? So again, they remind us of the information we know. A 100-pound person on Earth weighs 38 pounds on Mars, weighs 17 pounds on the moon. So one way you could do that is to say he weighs 17 pounds on the moon, and that is the same as 38 pounds on Mars. All right, now again, where are we getting that from? So 38 pounds on Mars is the same as 17 pounds on the moon. So that's where I got that information from. Okay. And then we are saying that he weighs 38 pounds on the moon, or pardon me, 34 pounds on the moon. He weighs 34 pounds on the moon, so we want to know how much he weighs on Mars. So our ratio is coming from here. We're not using the fact that he's a 100-pound person because we're not focusing on his weight on Earth at all. But 38 pounds on Mars is equal to 17 pounds on the moon. And we want to know 34 pounds on the moon is equal to how much on Mars. So how much he weighs on the moon, how much he weighs on the moon, these two need to be aligned. And again, you could do your cross products. So 38 times 34, multiply diagonally across, divide by the third value. And you end up getting 76 pounds. Now, I want to remind you also when it comes to these cross product problems, and I'm just going to look at the numbers and not the label for the moment, but that, the way that we're talking about solving it with cross products will work, of course, every time, but that another way you can think of it, especially since we've been doing some work with algebra, is instead of putting my question mark on the bottom, I could put a variable term down there, like x, okay? And then what I'm basically doing is multiplying these two and multiplying these two. That's the idea of cross products. So what's happening is when I take the 34 times 38, I'm getting 1,292. And that's going to equal 17 times x. Okay. So again, this is the idea of cross products. Multiply these two diagonally, multiply these two diagonally. And then, in order to get x by itself, we know from what we've been doing with solving algebra equations that we would divide by that 17. So my point is that is why we do that method of multiply these two diagonally and then divide by the third. Because you end up taking what we got as a product when we multiplied these two diagonally and dividing it by the 17. Again, this creates a giant 1, and 1,292 divided by 17 gives us 76 pounds. So the process is still the same, but it is important to understand that where you were getting that process from is that these two are being multiplied diagonally, these two are being multiplied by diagonally, and then we're dividing by this value because it's the coefficient on the x. And when you have more complicated problems with variables, it's important to know that process as to why we're doing it the way we're doing it. All right, for 6.137, you're going to evaluate, find the value. 1 2/10 minus 8/10 is 4/10. For the second one, we would do a keep change. So we would change it to adding the opposite. Because subtracting integers, remember, is adding the opposite. So I rewrote it here. And then negative 4 plus 2, of course, is negative 2. Here you would be also changing it to adding the opposite. But also we need to think about getting a common denominator. So first thing I did is the rewrite again. And then I would change them both to 44ths. So negative 6/11 would become negative 24 over 44. And 1/4 would become 11 over, trying to move this out of the way a little bit, 11 over 44. And since they are opposites, one's positive, one's negative, we subtract and carry the sign of the number that's further from 0 on the number line. So when you subtract 11 and 24, you get 13, but it's negative 13/44 because, again, this one is further from 0 on the number line. So the negative is associated with our answer. Here you're just multiplying across, so you get 4/15. Here you're multiplying and then placing your decimal point 1 decimal place in, so you get 4 8/10. And here I would probably simplify before I multiply. Divide 8 by 4 and get 2. Divide 4 by 1, or pardon me, 4 by 4 and get 1. So I get negative 10/13. Now, if you had not simplified before you multiplied, you would get negative, looks like 40 over, would that be 52? But then you'd still have to simplify by dividing by 4 top and bottom. Here they want you to rewrite these as an equivalent fraction, a decimal, and a percent. So for 6/18, I could divide both of those by 6, and my equivalent fraction would be 1/3. The decimal for 1/3 is 0.3 repeating, and the percent, which I should add a percent sign here, is 33.3 repeating percent, or 33 1/3%. Now, if you didn't know that 1/3 was 0.3 repeating, you could divide it on, a calculator or with long division. And then again, once you know the decimal, you're moving the decimal point 2 places to the right and adding the percent sign. 7/20, you could multiply by 2 top and bottom and get 14/40. Remember, with equivalent fraction, there's an infinite amount of possibilities, so you don't necessarily have to have the same one I'm giving you. And then for changing that to a decimal, 7 divided by 20 would be 35/100. And then that, of course, is 35%. 9/10, an equivalent fraction of that would be, in this case, I went multiplying by 5 top and bottom, so 45/50. But you could have multiplied by 2 top and bottom and got 18 over 20. I just thought this would be easier to get to a decimal, which was 0.90 or 0.9/9, which is 90%. 4/25, I multiplied by 3 top and bottom and got 12 over 75. Again, you could multiply by 2 top and bottom, get 8 over 50. You could multiply by 4 top and bottom and get 16 over 20, or 16 over 100, pardon me, which would make it easier to get the decimal, 16/100. And of course, it's 16% then. For 6.139, these were checkpoints. So again, things that they expect you should know from what we've been doing. And remember, you can check your checkpoints in your CPM ebook as well. 6 more than x would be x plus 6. 5 less than y would be y minus 5. Remember, less than means you're taking it away from this value. Twice a number x increased by 3 would be 2x plus 3. Here's your twice a number. Here's your increase by 3. The product of 5 and y, we know the word product means answer to a multiplication problem. So you're multiplying 5 and y and getting 5y. And then for the last part, they want you to go back and find the value of these if x is 5 or y is 8. Well, if x is 5, 5 plus 6 would give you a value of 11. If y is 8, 8 minus 5 would give you 3. If x is 5, 2 times 5 plus 3 would be 13. 5y means 5 times the value of y, which if it's 8 would be 40. And then that answers the part E. If you have any questions, please feel free to ask. Otherwise, that summarizes your homework corrections for 6.2.7. Thank you.